Hi to all shape lovers. In this video, I will teach you how to create perfect cone shapes from paper, using PowerPoint and a printer. I have created these various conical shapes using this method. Later in this video, I will demonstrate how I created them. Hi again to all shape builders. We will be creating conical shapes in this video, by using PowerPoint to draw the pattern, and a printer to output those patterns which we will later cut and turn into shapes. Take note that this is only applicable if you are building small shapes, that can be patterned from ordinary paper sizes, like A4, letter or legal size papers. If you want to build an insanely big model, you will need a plotter. For bigger models, you can also use the old school method of using compass and drawing the patterns directly to your medium. You can use this method if you are building dioramas, making small cake toppers, building some small-scale architectural models, and if you are in the mood of doing some fun. With a little knowledge of trigonometry and algebra, let us derive the formulas. First, let us consider the right circular cone. In a right circular cone, usually dimensions such as the base b, the height h, and the cone angle theta is given. The pattern to create this 3D shape is shown on the right. We have to derive the relationship or formula between the cone angle theta on the left side, and the enclosed angle alpha, shown in the pattern on the right. Most of the times, you will only be given either of the two dimensions from base, height, and cone angle, and you have to solve for the last missing dimension. Let us derive the formula for the right circular cones. We will use this formula in drawing shape patterns in PowerPoint later. In case that only b and theta is given, the tangent of theta is equal to half of b, divided by h. Therefore h is equal to b, divided by 2 times tangent of theta. Solving for slanted height s, the sine of theta is equal to half of b, divided by s. Therefore, s is equal to b, divided by 2 times sine of theta. If base b and height h is given, let us solve for the angle. The tangent of angle theta is equal to half of b, divided by h. Therefore angle theta is equal to the inverse tangent of b, divided by 2 times h. For the dimension s, you can solve that using the equation above. Let us solve for the circumference of the pattern on the right side. Circumference c is equal to 2 times pi times radius, and multiplied by the factor alpha divided by 360. Note that the unit of angle alpha is degree. Let us also get the circumference of the cone on the left. Circumference prime is equal to 2 times pi times r prime. Now as you can see, the circumference c of the pattern on the right is equal to the circumference of the cone on the left. Substituting their values, we arrived at radius r prime of the left cone is equal to slanted height s, multiplied by the factor alpha divided by 360. Now let us solve the relationship between theta and alpha. The sine of theta is equal to r prime, divided by the slanted height s. Substituting the value of r prime, we got the relationship that sine of theta is equal to alpha divided by 360. Or the theta is the inverse sine of alpha, divided by 360. Inversely, alpha is equal to 360, multiplied by the sine of theta. This is the relationship equation that we need. Let us consider the right circular truncated cone. This cone has its top flattened, or truncated. For this shape, there is an additional dimension, which is the internal radius for the pattern. The internal radius is equal to the slanted height s1. This will determine the radius of the truncated portion. But all other dimensions are similar to a regular circular cone. For a truncated cone, most of the time you will be given dimensions such as the big letter B, which is the base diameter, small b, which is the diameter of the truncated portion, and height h. First, let us solve for the angle theta. The tangent of the angle theta is equal to half of big letter b, minus half of small letter b, all divided by the height h. Finally, theta is the inverse tangent of big B minus small b, divided by 2 times h. Once the angle theta is known, you can now compute the total height denoted by capital letter H, and the slanted height S1, S2 and S. Deriving the relationship between the angles theta and alpha will be similar to the right circular cone. The same relationship is established, that is the angle theta, is equal to the inverse sine of alpha, divided by 360. This is example number 1. Let us create a paper funnel. In this example, we have to create the funnel whose dimensions are shown on the left. Both parts will be using the truncated cone formula. We have to compute for the cone angle theta first, before we can compute the other dimensions. I have created an Excel table to automatically compute the other dimensions. The most important dimensions for the pattern will be the alpha, dimension S or the outer radius, and S1 which is the inner radius. They are highlighted in red. Let us draw the pattern in PowerPoint. Computed value of S is 11.2. In drawing the circular object, we need to set its height and width. The height and width is equal to the diameter of the circular pattern, which is twice the radius, and will become 22.4 centimeters. So let us set both value, shown in the right side, to 22.4 centimeters. Don't worry if the object exceeds the printable page, we will only need a portion of it in the pattern. Let us remove the shape fill and set the shape outline to red color. Let us draw the inner circle or radius. The computed value is 2.2 centimeters, so let us set twice of this value on the height and width of the object. Let us also remove the shape fill and turn the shape outline to red. Let us align first these two objects by grouping them, and then clicking the Align Center and Align Middle. To draw the angle alpha, let us first draw a horizontal line. The PowerPoint has snapping function, so let us snap both its ends to the circle. Now, let us copy this line. Let us rotate this line by the angle alpha. With the line selected, let us set the angle to 161 degree on the format shape on the right side. Let us align all the shapes by selecting them all, and then aligning their centers and middles. This is now the final pattern for the part A of the funnel. To draw the pattern B, let us first draw the outer radius S. The computed value of S is 40 centimeters. Let us set the height and width equal to the diameter of the circular pattern, which is twice the radius, and will become 80 centimeters. Again, don't worry if the object exceeds the printable page, we will only need a portion of it in the pattern. But make sure to place the upper half portion of the circle in the printable area, because this is where we are going to create the pattern. Let us remove the shape fill and set the shape outline to red color. Let us also draw the inner radius, which is 30 centimeters and will become 60 centimeters both for height and width value. Let us zoom out the page so that we can see the big circular objects. Similarly, let us first align these two shapes. Let us now draw the horizontal line. Let us copy this line, and set the angle of rotation to 9 degrees. Select all the objects then align again using the Align Center and Align Middle. This is now our final pattern for part B of the funnel. Let us print the patterns then do the actual shape building. Before printing, let me teach you one of my lessons learned here. Take note that if you want to achieve correct printed size of your drawing versus the PowerPoint dimensions, There is a trick here that you must observe. You have to set your slide size similar to your actual paper size. In my case, I created a separate PowerPoint file, and I customized the slide size to legal size as shown here. To customize the slide size, go to the Design menu, and click the slide size on upper left. Click the custom slide size and set the width to 35.56 centimeters, and the height to 21.59 centimeters. Similarly, you have also to set your printer to the same paper size. Let us go to the printer settings, and set the paper size to legal size. Okay, with this I am good to go. This will ensure that my drawing in PowerPoint will be printed out the same size an actual printout. This is now the printed pattern. Let us cut the pattern A and pattern B. The pattern generated is the exact dimensions of the cone. Therefore you have to leave some excess portion for the connection. So left some excess portion on the inner radius portion. This will be used for the connection to the lower part of the funnel. Let us cut the connection flaps in smaller increments for easier connection. Cut it along the line from the center of the circle, going outward. Let us also cut the pattern B. Here, I also left an excess portion for the connection later. Let us now assemble the shapes. First for the part B, just roll the pattern and align according to the printed marking. Let us fix this using an adhesive tape. Let us do the same thing to the part A. Let us bend the connection flaps outward for easier connection later. Similarly, let us fix the connection with an adhesive tape. You can also use any other adhesive you find more convenient to you. Let us now join the two parts. Let us insert the part A into the funnel. Adjust the alignment of the two shapes. Join them using adhesive tapes. I just realized now that I must have hidden the connection flaps inside the part B for a more cleaner look. I will do that on my next project. So here is now the completed funnel, perfect in size according to our drawing. Let us create a lighthouse in this example too. The dimensions are shown on the left. The lighthouse is composed of 4 separate parts and we have to compute the dimensions of each of them. 2 parts, namely the base and the roof, are conical in shapes, so we will use the formula in previous examples. For the other 2 cylindrical parts, this is just simple computation of the height and the circumference. This is the computation for part A, which is the base, using the truncated cone formula. This is also the computation of part B, which corresponds to the roof of the deck. We used the right circular cone formula. For the portion C, which is the cylindrical portion of the deck, we will just compute the height and circumference. For the portion D, which is the deck platform itself, this will only be based on the given diameter. Using the previous method of drawing the shapes in PowerPoint, here are the final pattern for a plain design. However, I would like to try creating printed pattern on the surface of the shapes, like the red strip of the base, the red roof, the windows and doors on the deck to make it more realistic. So let us embed some of those design in this another pattern and see the difference. I will show you how I draw the red strips for the base. We are going to create shapes according to the dimensions shown here. Since the outer radius is 40 centimeters, the diameter of the farthest strip will be 80 centimeters. We will create strips at 80, 76, 72 and 68 centimeters from the center of the cone pattern. First, let us do the outer radius and inner radius of the base. Let us also add the horizontal line and the angled line. Let us align all shapes. To draw the strips, we have to use the block arc from the basic shape. First let us create the block arc with the 80 centimeters diameter. As you can see, there are shape controller here and we can freely change its shape to fit our pattern. Let us zoom in the drawing, and adjust temporarily its size. To create the other strips, let us make another 3 copies of this block arc. Change the height and width of the second strip to 76 centimeters according to our design. Let us change also the third strip to 72 centimeters, and the last strip to 68 centimeters. Now let us select all the shapes and align their centers and middles. Let us zoom in again to make the final adjustment. But wait, let us change the shape fill to red, and remove the outline. Now, let us make the fine adjustment for each strip. For the last strip, let us pull the shape up to the tip. This is now the final design. I also added red color on the roof, black and red color for the deck floor and railings, and windows and doors for the deck. These are now the printed patterns in legal size paper. I have 2 patterns here, the plain design and the one with embedded colors and design elements. Let us cut both of them. Let us now assemble both designs. These are now the assembled lighthouses, a plain white lighthouse and a colored and more realistic lighthouse. Sorry, the rails on the deck are messy. This is another example, and let us create a rifle scope. It has 2 parts with conical shape, while the rest are cylindrical. We will only create the main body in order to shorten this video, and will not create the details of several dials. The dimensions are shown on the left. The computed dimensions are as follows. This will be the pattern for the two pieces of conical shapes. We use the truncated cone formula in computing the dimensions. These are the patterns for the cylindrical parts. Let us print and cut the patterns. This is the printed pattern of the riffle scope. It has two patterns for the two conical shapes, and another 3 cylindrical pattern for the other parts. Let us start cutting. This is now the completed rifle scope. Pardon me, this is not a scale model and I just put a random dimensions. I also built other shapes like the industrial chimney, silo, and traffic cone, where I embedded colors and designs to make them realistic. The methods are just similar to my previous examples. I do hope you learned something from this. Please give me likes, leave comments and subscribe to my channel if you find this helpful. That's all and bye bye.